look at OR probability. OR probability is used just when you are selecting one object. So selecting one card, or rolling the die one time, or selecting one person and asking a question. But it's still a compound event in that you're looking at, oh, is it red or is it black, or is it a queen or a king? Okay, so you are still dealing with a compound event, but you're just looking at it happening one time, selecting one card, rolling the die once. Okay, so keep in mind you're selecting one. Okay, so OR probability, there's two rules with OR probability. We'll start with a simpler rule, is when the two events are mutually exclusive. So this is the mutually exclusive addition rule. OR probability uses addition. Okay. So when the two events are mutually exclusive means that there's no overlap. So if you were to do a Venn diagram of the two events, there would be no overlap between them. Something like if you're choosing one card and you want the probability that is a king or a queen, you can't have both. You can't have a king and a queen at the same time, so you have no overlap between those two events, and these two events are mutually exclusive. When that happens, the probability of the two events A or B happening, you take the probability of the first event and you add the probability of the second event. So the probability of A plus the probability of B. Okay? If they are not mutually exclusive, so this is our general addition rule, used when the two events do overlap. So when you have a Venn diagram, you are going to have an overlap between the two events. Something like with cards, the probability of a king or a spade. You have a king of spades that lands in that overlap between the two events. Still only selecting one card, but you've kind of got a compound event happening and there's an overlap between the two. If that happens, then the probability of A or B, we find it by taking the probability of A, adding the probability of B, and then subtracting that overlap between the two events, A and B. We have to subtract this off because if we were not to, we would count this event twice. As the example with the king and the spade, you would count the king of spades here with the kings, and you would count the king of spades here with the spades. So you've counted that one event twice. So you have to subtract it off. So let's do a few examples of some OR probabilities, keeping these rules in mind. So we're going to look at cards, and we're going to select one card. Select one card, and we're going to find some probabilities when selecting that one card. Okay, so let's first look at what is the probability of, for that one card, of it being a king or a heart. So we know this is OR probability because it clearly says OR first of all, and because we are only selecting one. We can't use OR probability if we're selecting more than one. We would have to use something else. So we're selecting one, and we've got the word OR, so that makes it pretty clear that we're using OR probability here. So the next question we have to ask ourselves is, are these two events that we're looking at between the OR, are they mutually exclusive? A king and a heart when you're selecting one card. Well, they're not, because we've got the king of hearts. So we've got an overlap between these two events where the king of hearts is an and between the two. It's a king and it's a heart. So these are not mutually exclusive. I'm going to use this abbreviation, not ME, for not mutually exclusive. So we'll use our general addition rule. So we'll take the probability of a king plus the probability of a heart, and then we'll subtract off the probability of both a king and a heart. And this is, once again, because there's an overlap between these two events. There's a king of hearts that's counted here and it's counted here. We don't want to count it twice, so we subtract it off once. So let's fill this out. The probability of a king, there are 4 kings in a deck of 52 cards. There are 13 hearts in a deck of 52 cards, so the probability of a heart is 13 out of 52. And then there is 1 card that is both a king and a heart, the king of hearts. So we'll subtract off that overlap. Okay. Do this and get 16 out of 52. Both divisible by 4, so this reduces to 4 out of 13. So there's an OR example that is not mutually exclusive. Let's do another one real quick. Let's still select 1 card and find the probability of a king or an ace. So OR probability, once again, clearly saying the word OR, selecting 1 card, so it will work. And the next question we ask ourselves is this mutually exclusive? Is there an overlap here? A king and an ace, can we select 1 card that is both of those things at once? No, we can't. So since there's not an overlap here, we can save ourselves a little time and not have to subtract it off. So we can just simply take the probability of a king and add the probability of an ace. Okay. If we were to subtract it off, accidentally get the wrong rule and subtract it off, like if we had the probability of a king and ace here, it would work out because the probability of getting both a king and an ace is actually 0 because you can't draw a king and an ace at the same time. So the general addition rule, and that's why it's called the general addition rule, would work here because of the fact that there is not an overlap between the two. So general addition rule always works, but we want to save these mutually exclusive addition rules only for when they're mutually exclusive. It just saves us some time to not have to think of that if we identify the fact that they are mutually exclusive. So probability of a king, 4 out of 52. Probability of an ace, 4 out of 52. So the probability of getting either an ace or a king is 8 out of 52. Both divisible by 4 reduces to 2 out of 13. Okay, so there's the OR rule for probability demonstrated and a few examples for that. Thanks.